Hey, today we're going to work with analog output signals on our Siemens PLC, and we are going to try to control this Powerflex drive. Purpose of today's video is using our Siemens PLC. We want to wire this to our drive to start in forward and reverse, and we also want to wire an analog output to this Powerflex drive so we can control it. The goal is to control it from this HMI, so hopefully we can end with a start button, a stop button, maybe a forward, reverse toggle, and then a speed selector. So let's go ahead and get started, and we'll start by wiring this drive to the PLC. To get started wiring this thing, I want to show you how I'm going to wire it. I won't film me physically doing all this wiring, but I want you to know how we're going to do it. So anytime you come up to a Powerflex drive, whether that be a 440, 525, 523, 700 series, it's always nice to get the quick start reference guide up. This helps you with basic mounting, basic wiring, I/O wiring, what terminals do what here on the Powerflex drive, and some basic parameters for setting up your drive to whatever motor you have. So it's always a nice way to start by opening up the quick start guide and looking down through that. If I go back up to the wiring diagram here, right here. So this is our wiring diagram for our terminal blocks right here. You can see a couple different ones. So I am going to do a 2-wire forward reverse. So I will be wiring an output of my PLC to number 2 and another output of my PLC to number 3 to start in the forward or start in the reverse direction. I will be providing my own common. So I will be doing an external wire. I will be providing my own common from the PLC. And then down here on the analog side, right here, I will be providing a 0 to 10 volt reference. So I will be using the analog common as well as the 0 to 10 volt input. So 13 and 14. If I wanted to do if I wanted to do the 24 to 20 milliamp, I would do 14 and 15. So those are the wires I'm going to be connecting here. I will pop up from the full user guide. I will pop up those images here in the video, and I will get this thing wired, and we'll come back when we're ready to power on. All right, I have this Powerflex all wired up. To go over the wiring a little bit here, refer to not the quick reference guide, but refer to the Powerflex manual. I'm looking at page 46 right now, which tells you how to wire up all of the different types of start stops. So I am under a 2-wire SRC control, forward and reverse. I am wiring an external wire, meaning that I am supplying 24 volts from my PLC to the drive. What that looks like is I have 24 volts going to my stop. I have a common going to 4, terminal number 4 for my common. And I have 2 wires going to 2, one going to 2 and one going to 3, 2 being my start forward from an output on my PLC, 3 being my start in reverse from an output on my PLC. So that's my start stop. Then I have these smaller wires here. I have a red and orange. These are my 0 to 10 volt analog signal coming out of my analog output card. So we're going to send 0 to 10 volts through a common and through a positive to terminals 14 and 13. Once again, just refer back to that quick reference guide and or the full manual to understand this wiring process. We have a couple parameters to set up in our drive here to make sure all this works. So I'm going to go ahead and power on the drive, and we'll come back and set the couple parameters that so then we can start on the PLC. All right, we need to make a couple parameter changes here on our Powerflex to make all of these wiring changes we just made down here take place. Right now it is under default settings, which is these the start and stop button and the speed pot, which we want to control all of that through our PLC. So we have a couple parameter changes we need to make, 4 of them to be exact, and then we'll be up and running. Obviously, make sure all of your motor parameters are in there. I've already gone and set this one up, but make sure everything from your motor nameplate is already in your drive. We are just concerned right now about the start stop. So I want to hit my select button, and I want to find my P parameters. I want to hit enter, and the first parameter we're looking for is P46. There we go. P46, if you're looking at the quick start, or if you read across the screen, that is our start source. So this is telling the drive how is it going to start, where we are going to start via the terminal blocks. So if I hit enter here, we can see by default it's on number 1. We are going to change that to number 2 for terminal block, digital terminal block. And we'll hit enter and escape. All right, so the next parameter we want to control is P47. That is our speed reference. We'll go ahead and hit enter. It is set on 1 by default for the speed pot. We want to make it 5. We want to change it to 5, 0 to 10 volt input. So now our speed reference will be controlled by whatever it is getting on the input side here. Enter and escape. We're going to hit escape twice. So our letter is blinking, and we're going to go to the T's. 2 parameters we need to check here is T62. We need to make sure that is on 48 for 2-wire forward start. And we need to make sure and then we need to go to 63, and we need to make sure that is on 50 for 2-wire reverse. If one of those is off, or if both of those is wrong, our forward reversing will not act right down here. So those are the 4 parameters we need to set in the drive. We can hit escape back to our main display screen, and now we are ready to jump into the PLC side. All right, over here on our TIA portal side, I have my project pulled up. I have my PLC and an HMI added already. Couple of setup things. If we come into devices and networks and click on our PLC, we need to add our analog card. So I have to come over here to AIAQ in the catalog, and I have to grab what the right version I have. In this case, I have a 32. So I will drag that into the 32 slot. Next thing I have to do, I'm going to drag this up because I'm going to click on that module and click on properties. I have to configure my inputs and outputs that I'm using. So over here on the drop-down tree, you can see analog inputs and analog outputs. I have wired this drive up to channel 0. Channel 0 is already on voltage, and it is 0 to 10 volts. So that is already set up. If I needed to change it to current, I could change it there. or if I wanted to keep it on voltage, I could keep it there. All right, so that is set up. Now we need to come over to our PLC. We need to do a compile. And remember, we changed a piece of hardware. So I'm going to do a compile hardware, rebuild off, and then I'm going to do a hardware configuration download to tell the PLC, hey, this is the new hardware I've added. This is the configuration change I have made to it. And so it is ready to go. Okay. And download to device, hardware configuration. With that, our PLC now knows what modules it has attached to it. So we will now, after this is finished, we will now start adding our tags to control this. Next thing we need to do is come into our PLC tags. I have some of my generic tags here: start, stop, e-stop, light, and then some inputs and outputs. I will be using the start and the stop button to start and stop the drive, so those are good. I won't need a light. I do need to add the outputs that will be controlling the Powerflex. So to keep them away from the ones I already had, I added them to 6. I added them to 0.6 and 0.7. You can notice here I only go to 0.3. So I just need to add those in here. I'll start with Powerflex run forward. And that is going to be output 0.6. And I'll make another one called Powerflex run reverse. And that is output 0.7. So those are the two digital outputs that will be controlling our drive, whether it runs forward or whether it runs reverse. Next thing I have to add is I have to add that analog signal. So I will make a tag called Powerflex speed. That is going to be an output, but not of the digital type. So I need to come to devices and networks and PLC, and I'll need to zoom in here to see what that address is. So it's looking like QW96 is what we need. So I'll come back to here. I will change it to an integer because it is not a bool. It's not on or off. And over here in the dropdown, I will keep it a Q because it is an output. It is a word. But down here, we will call it 96. And we are done. So these are the 3 tags that we need to run that Powerflex. They associate with the wires that we physically wired from our PLC to our Powerflex. So now using this combination of tags plus a couple memory tags that we will have to make, that is what will get us going. Now that we have our tags made, let's come to our program blocks and let's program this Powerflex to start and stop. So here in our logic, we know that we need to start the Powerflex in forward. We also know we need to start the Powerflex in reverse. So we know our 2 objectives there. Now, between using the start and stop buttons on the on my HMI panel here, and potentially a toggle switch on our HMI, we can start and stop the drive to run forward or to run reverse. I'm going to do a little setup here, and I'm going to come back and show you what I did. I'm going to make some changes on the HMI, and I'm going to make some changes here in my program. All right, I'm back. Let's take a look at some of this program work I've done. I started up here with a start-stop latch, right? Start button, stop button. That turns on a tag called, I'm calling drive enabled. So when this circuit is started, the drive is enabled. That drive enabled latch itself to keep that a latching circuit. And I threw that light there just so we have a visual here when we switch back to the camera, that we can see, hey, if the light's on, we know the drive is enabled. Now down here, I commanded our forward or reverse. So I have two lines here. You notice drive enable starts both lines, but then I created a tag called forward reverse toggle, one being normally closed, one being normally open. And that is the button we are going to use to decide whether it's running forward or running reverse. If I come over to our HMI here, you can see I've added this button right here. It is just a simple toggle button, one forward, one reverse, and now you can toggle between the two, changing this logic over here to decide if I'm sending output for reverse or output for forward. So that's my basic start-stop logic. I have tested this, and my drive will run in forward or reverse. It is obviously not spinning the motor because we do not have a speed reference yet, but that's what we're going to work on here now. One thing to take note, yes, I know I'm programming in the main OB1, and I could be adding blocks here. For these quick lab videos, it's easier enough to just throw it in OB1, but notice a little bit of organization, right? I have a start-stop latch. I have Powerflex run bits for forward and reverse. And then down here in network 3, we're going to do speed reference. So if you remember to our analog input, we normexed the counts coming from our sensor. Then we had to scale it to whatever units we wanted, whether it was 0 to 100%, whether it was a millimeter distance. We need to do exactly that, but we're starting with our scaled value and working out towards our counts. So if I come over here and I go to my instructions and conversion instructions, if I drag a scale X in, or a norm X, then I drag a scale X, this is going to be the start to our speed setting. So over here for this, we're going to give it a 0 to 100 value. So on our screen, we will be working in percentage. So I'm going to make this tag here called percentage speed. I'm going to go ahead and define that. That is going to be a real number, a global memory, and just let it, the reason I like defining tags like this is just let it decide what tag it is. I don't really care what MD2, MD10, I don't really care what that is. Just let the PLC say, hey, this is the next available one. So we have percentage speed. This item will be controlled via our HMI. Remember, we need to normalize that. So make a tag called normalized value. Also go ahead and define this. And that is also, that will be a real. And that normalized value, remember, is just used to transfer from our norm X to our scale X. Then over here on our scale X, this is where we need to convert this into counts. Because remember, the PLC does not handle analog signals. It converts it to a digital count, and then the analog module processes that into a 0 to 10 volt figure. So we need to be in that count range. I'll pull up that chart here just so we can see what this number is. Obviously, I know 0 is our bottom. Our top is the number 27,000. I believe it's 27,648, but let me pull it up and check. So yeah, jumping back over to the PowerPoint we looked at in class, 27,648 is equivalent to 10 volts, and 0 is equivalent to 0 volts. So there is our scale. There's our span. So our bottom is going to be 0, and our top is going to be 27,648. So if I come back over here, our top, 27,648. Now, the last thing we have to do is we have to add that output tag. That is our integer tag, and that is QW96, which we already made. And now that is the value going to our PLC. So we're starting at a percentage, we're normalizing that, and now it is going to our Powerflex. So the last thing we have to do here is just some HMI work because we need to visually make this change. So I'm going to compile and download this PLC program, and then we'll jump over to the HMI and finish up there. Okay, back on our HMI side, this is what we got. I have that toggle switch that toggles between forward or reverse, selecting the direction of travel. I have added a text element, speed in percentage. I have obviously changed the size of that, but I have tied that to the tag called percentage speed, and I have made it an input, meaning that I can, from the HMI, input a value. So when I click on it, I will get a keypad and I can type in a percentage speed. I also mess with the format just so we only see those 3 digits. So now it's time to compile and download both our PLC program and our HMI. I will boot the camera up here and get it set up so we can see all of that and hopefully test it. All right, we are here with our PLC program downloaded as well as our HMI program downloaded. We have our logic written. We have our start stop. We have our forward reverse toggle, and we have our norm X scale X. If we go ahead and just test our HMI here, if we push on that, we get our keypad. And if I put a 50 in here and press enter, I see 50% here on my HMI. We can also see over on our program side 50, and it is giving out that 13,000 counts. So now let's set this to 100 and hit enter. Now our buttons here should control that motor as long as we've done everything correctly. Let me get the program in screen here. Let's go ahead and try it. Green button. Green button starts up that program and starts the Powerflex. Red button stops it. If we notice the direction of spin there, we can change it to reverse. And now it spins in reverse. You can change from forward to reverse live. It's just going to ramp itself down and then start back up. So if I hit the forward to reverse toggle, slows itself down, and then starts up in the reverse direction. To do our speed, we can do that live. So let's do 25%. Enter. And we can see here that our Powerflex has slowed this motor down to 25%. And it doesn't have to be in by 25% increments. It can be anything. We can go to 5%. We can go to 71%. And we can stop it. So there we go. That's the program, the setup, the wiring, the configuration of controlling a Powerflex 525 with our Siemens S7-1200 PLC, both on a digital start-stop and an analog speed reference.